integers just 0, 1, 2 dots or r minus 1 forms a complete set of incongruent residue modulo r. Basically what happens, see these are the basically equivalence classes 0, 0, 1, 2 dots on r minus 1. It is like this. So it will be what 0 plus kr, where k belongs to integer. This is what 1 plus kr. This is what 2 plus kr. This is r minus 1 plus kr. So these are what equivalence classes. These are equivalence classes. Equivalence classes, they are basically partition of integers. Their disjoint union gives whole set of integers. And also they are disjoint. Union disjoint means that if you intersect, if you take intersection of all these equivalence classes, you will get empty. Is it clear? All these classes are non-empty and they are disjoint from each other. And if you take the union of disjoint union, you will get whole set of integers. So they are form partition. So and also 0 does not belong to here. Means 0 and 1 have no relation of congruence. The relation which I have defined already, that is A congruent to B modulo R. It implies that when R divides A minus B, correct? So integers 0, 1 to R minus 1 forms a complete set of incongruent residue modulo R. Also, if you add opposite integer m to all, that is m, m plus 1, m plus 2, the result will be what? Same. It will again form a complete set of incongruent modulo residue R. Correct? But it may be possible that any one of, for example, 0 will go in any one of, it may go out of all, it may go in the equivalence class of any one. For example, similarly, 2 will be belongs to equivalence class and may go in m plus 1 or it may go in m plus 2. It will go in out of all equivalence classes, it will go in only one. Isn't it? In a similar fashion, r minus 1 will belongs to any one of the equivalence classes. M is the equivalence class, m plus 1 is the equivalence class, m plus 2 is the equivalence class, m plus r minus 1 is the equivalence class. We will use this fact. That's why I am telling you all these things. So let's see how. So it follows that there exists G such that G lies between R minus 1, 0 and m plus G is congruent to 1 modulo R. Which implies m plus G is congruent to 1 modulo R. It implies Km plus G is equal to K modulo R. This thing I have told you that it means that there exists some G between 0 to R minus 1 such that m plus G will be congruent to any one of this, say any one of this, that is say m plus G is congruent to 1 modulo R. It may be possible there is some Z such that Z lies between 0 to R minus 1 and m plus Z is congruent to 2 modulo R. In a similar way, there exists some, say, H between 0 to R minus 1 and m plus H is congruent to 3 modulo R. It's like that. So m plus G is congruent to 1 modulo R. So K plus m plus G is congruent to, of course, K modulo R. Now, of course, it is for every K belongs to a set of natural numbers. Now see what. powers of a की power m plus g की power k of a की power m plus g for k is equal to 1, 2 up to r exhaust k. Thus K is cyclic group of order R generated by an element by an element a की power m plus. So this is try to understand this. How the a की power m plus g becomes generator for this cyclic group. That is, I mean to say that k a is equal to a की power m plus 1 or from a की power m plus r minus 1. I am saying that it is generated by an element a की power m plus g. Correct? It means that every element of this is a power of a की power m plus g. Correct? See, no doubt, when you take a की power m plus g, the power, take any power, it will certainly go in k. In closure property, no problem. Now you see one thing, that km plus g is congruent to k modulo r, and k has values 1, 2, r, and all of you well know that 1, 2, r, all are equivalence classes and they are distinct from each other. No two are congruent to each other. Correct? So all are distinct. So there are different choices. So when there are different choices, and every choice that any power of a goes in k, and all are different and are different choices, so it means that it will exhaust whole k in the same sense. It means that it is generated by an element a की power m plus g. So in this way, k becomes cyclic group generated by a की power m plus g. Correct? And now the last thing is to identify the identity of this group. Once it is group, so it must have identity. So what is the identity? So remember, we will find out the idempotent element, because in a group, idempotent element is the identity element of the group. Correct? So we will find out the idempotent element. For this, if we choose Z, so that Z lies between r minus 1 and 0, and m plus z is congruent to 0 modulo r. Then a की power m plus z square means that a की power m plus z into a की power m plus z. So you see that a की power m plus z, this is a fact, m plus z is congruent to 0 modulo r. There must exist some that between 0 to r minus 1 in the same fashion. So m plus z will be qr, that is this qr. Now a की power m plus qr into a की power z. This is what a की power m into a की power z. So this is a की power m plus z. So you see, this is idempotent element. It implies what? A की power m plus z is idempotent in a, which implies what? Which implies that a की power m plus z is identity element in G. Correct? identity element in K. So in this way, theorem 1.22 is proved. We have done all. We proved K is cyclic. First we have proved K is group, then K is cyclic, and also we identify the identity element by identifying the idempotent element of K. So in next lecture, I will also give the example of this theorem. That I will give you example how we find out the idempotent element, identity element in K. So I stop here. Thanks.